Okay, so yesterday when we started this, okay, we were talking about how this cannonball is being fired at a 40-degree angle at 140 meters per second. I think we actually got to the point where we had figured out how far it was going to travel. It was like 990 meters or something like that. Okay, so we're just going to quickly walk through that again, and then we're going to have a look at how we calculate the maximum height. There are actually two ways to do that. All right, so anytime we have a projectile that's launched at an angle, we need to set it up, well, any projectile wouldn't be a problem for that matter, into vertical and horizontal parts. And then we need to find the components, vertical and horizontal, of the launched or projected velocity. In this case, the 140 at 40 degrees above the horizontal. Okay? So, if I want to calculate the horizontal component of that, okay, and of course I want to remember that horizontally, this object travels at a constant speed. So in the horizontal dimension, there's no acceleration. Okay? The horizontal dimension is governed by V equals d over t. So if I want to calculate d horizontal, okay, I'm going to have to find the adjacent side to the 40-degree angle, because this will be the horizontal component of my projected velocity. So I'll go cos of 40 times 140 meters per second. So cos of 40 times 140. All right, so horizontally, this cannonball is traveling at 107.25 meters per second. Okay, I have to do the same thing for the vertical part, but what I have to realize is that in the vertical part, the object is undergoing accelerated motion due to gravity, which means when I find its vertical component, that is only the instant it is launched. After that, gravity will start to take effect and it will be changing its velocity as it flies through the air. Okay, so all we're calculating with that is the initial vertical velocity. Okay, so that'll be the sine of 40 times 140 meters per second. All right, so that's 89.99 meters per second, and it's up. All right, so I've got positives and negatives this time in my acceleration parts. Okay, or in my vertical component, I have positives and negatives because gravity is taking effect and there's a change in direction for the object. All right. They're asking me, how far does it travel horizontally? I have to assume that the launch point and the impact point are level. Okay? They're at the same height, so there's no vertical displacement between those 2 points. If that's the case, what's my final vertical velocity? Negative 89.99. What goes up must come down. And all that's happening vertically is the object is starting here and going up to this height and then falling straight back down, exactly the same distance, at exactly the same rate of acceleration, which means when it gets back to the ground, it's going exactly the same speed it was going at when it left, just in the opposite direction. Okay, everyone all right with that idea? Okay, so VF then is going to be negative 89.99 meters per second. All right, so the first part of this question is calculate how far this thing goes horizontally. What am I missing in order to get that? No? Time. Okay. Is time able to be shared between vertical and horizontal parts? It's the only thing that can be shared between horizontal and vertical parts. Okay, can I calculate time at this point? Yes, I can. And notice I said at this point and not at this time, so I didn't confuse you. Okay, I need to calculate time. I've got acceleration, initial vertical, and final vertical velocity. That means I can use this formula right here, because I've got 3 out of the 4 parts, and the 4th part is what I'm looking for. Okay? All I have to do is manipulate for t, which means t equals vf minus vi over a. So that'll be negative 89.99 minus 89.99, okay, divided by negative 9.81. The negatives are all important here. If we forget any of them, we're going to get the wrong answer. Okay? All right. When I do this, so I'm going to take that number there, okay, and I'm going to multiply it by 2. Why am I doing that? Because it's the same as going negative 89.9 minus that same number. I'm making it twice as big. Okay? And I'm going to divide that by 9.81. Okay, so all that stuff I said about making sure you kept them all negative, did I just totally ignore that? I did, but it was okay. Why was it okay? The final answer ends up positive anyway. You can't have a negative time, right? You can't go back in time. So, all right, so this thing is flying through the air at 18.35 seconds. In the air for a long time. Okay? So that number, 18.35 seconds, can go to both sides. So I'm going to put it over here with my horizontal information. And then I'm going to use it to calculate d. I know how fast the object's traveling horizontally because I already calculated that. I have the time because I just calculated that. That will allow me to get my horizontal displacement. So 107.25 times 18.35. Obviously, we'll use our fully accurate numbers from our calculator. Okay. So this thing is going to travel a long way, almost 2 kilometers. Okay. In fact, if we do this to the right number of significant digits, which is 2, it is 2 kilometers. Okay. It's going to be 2.0 times 10 to the 3 meters. Everybody all right with that? Okay. So this thing travels pretty far. Is it logical for a cannonball to fly that far? Absolutely. Okay. You don't fire a cannonball at something that's 20 meters away. The explosion could get you both. Okay. You want the explosion to be a long way away, like 2 kilometers. Okay. All right. So we've got a horizontal displacement of 2.0 times 10 to the 3 meters. All right. So that's the first part of that question. They wanted me to calculate horizontal displacement. And all I've really done here is things that we've done individually a whole bunch in this unit already. I calculated vector components, okay, found x and y. I did an acceleration calculation, which we've done a whole bunch of. I did a v equals d over t calculation, which we've done a whole bunch of. Okay? There isn't any one step in a projectile motion question that's difficult. It's getting all the steps. Okay? It's knowing I have to do all of these steps. That's where kind of these become maybe a bit challenging, is remembering what steps have to be done and when. All right, so that's what we got to yesterday. And then near the end of class, we were talking about how do we calculate the maximum height of the object. Okay, so where does the maximum height occur? Right in the middle. The maximum height is going to occur right here in the middle of the flight. Because again, from a vertical perspective, all this object is doing is going up and back down. Okay, so its maximum height occurs at exactly the halfway point of the flight. Okay. Is VI still going to be 89.99 meters per second? Is the fact that I'm looking for this change what happened over here? Not at all. Okay, so this is still going to be VI. VI is still going to be 89.9. This object is still being launched, okay, that way. Initial velocity doesn't change. Does the acceleration change? This is still on Earth. Gravity is still 9.81. That's not changing. What is going to change? The final velocity, yeah. Okay, my final velocity is not going to be the same as my initial velocity. Otherwise, this thing's just going to keep going. Okay, it's never going to come back. So, how fast is the object going vertically right here at its maximum height? okay? 0 meters per second. If I throw this thing up in the air, when it's at its maximum height is where it has slowed down, stopped for an instant before falling back to the ground, okay? So at this point here, VF is 0 meters per second. What else is different there? The time. Yeah, this is the halfway point. We were just dealing with the whole flight a minute ago. Okay? So now, rather than having the time be 18.35 seconds, now it's going to be 9.175 seconds. Okay? Because it's half the time now. Okay? All right, so those are the things I have to remember about the maximum height. Okay? The time is half of the total time, and VF is 0 meters per second. So I know time, VF, A, and VI, and I'm trying to find D, the vertical displacement at that point. Which formula could I use? Do I have choices? Yes. There are two formulas I can use. Okay? Either one of them will arrive at the correct answer. Okay? My preference for this is to not use time. The reason that's my preference is, in my experience with both myself and students, I forget to divide the time in half. And I end up using the total time, which gives me a completely different answer. Okay? So I try not to use the formula that involves time. But it's perfectly valid to do so, provided you remember to divide the 18.35 by 2. Okay? My preference is to use this formula. Okay? I know what VF is. I know what VI is. I know what acceleration is. And I only had to calculate one of those numbers, so there's less chance I screwed something up along the way to use this formula. Okay? So I need to manipulate to find D. So I'm going to subtract VI and then I'm going to divide both sides by 2A. That'll leave me with D. Are we okay with what I did there? Now I just have to plug in my numbers. So 0 squared minus 89.99 squared divided by 2 times negative 9.81. Negatives are important, and this time I'll keep them only. Okay? All right. So we got 0 minus that number squared, okay, divided by negative 19.62. That's 2 times 9.81. Okay. All right. So this thing is going to reach a maximum height of 413 meters, but we only have 2 significant digits. So 4.1 times 10 to the 2 meters. So it's going to travel 2 kilometers and reach a height of over 400 meters over the course of its flight. Okay, so that's the way I would prefer to do it, but as we said before, it's perfectly legitimate to use this formula as well. The benefit of this formula is you don't have to manipulate it. It's already set up to solve for D. As long as you remember to divide the time in half, you'll get exactly the same answer. You'll have 89.99 times 9.175 plus 1/2 times negative 9.81 times 9.175 squared. Okay, and we should get exactly the same answer here. So there's that number right there. Hang on, I gotta do this in brackets, okay. that number over 2. And I want multiply, not divide. See why this way sucks? It takes so much longer. Okay. Plus 0.5 times negative 9.81 times, I gotta do all that again. I'm just gonna put in 9.175. We'll be slightly off, but it'll work. $412. Because I squared that number that I rounded off, that we got a slightly different number. If I had actually done all the work, it would have got exactly the same number. Okay? Everybody with me on that? 2 ways to go about that. Okay, questions on what we did there? Okay. All projectile motion questions basically break down to those things. Okay? The example I just showed you is what's going to be on your unit exam on Thursday. Not the exact numbers, but I'm going to ask you to do those things. Calculate the horizontal distance traveled and the maximum height of a projected projectile. Okay? That's what I'm going to ask you to do. I'll also ask you to do that on your final exam. So if you're making notes about what might be in your final exam, that's going to be on there. And a few other things. All right. Let's have a look at some examples of really bad movie physics. See if you guys can find the mistakes here. You can. The clip we just watched was the General Lee jumping the riverbed. Here's what we know. The General Lee is moving at 32 meters per second when it leaves the pile of dirt / ramp, okay? And it's angled at 20 degrees. What is the distance across the river, and how high does the General Lee fly? All right, so we're looking for 2 things. Here's how that question starts. Okay, 32 meters per second. Okay, 20 degrees above the horizontal. So remember, you want to treat the 2 parts of this separately, vertical and horizontal. Right, but that's the setup. Give you a few minutes and see if you can figure that one out. It's just like the one we did. It's exactly the same as the one we did a few minutes ago. Yeah. Let's have a walkthrough of this one here. So just like the last one, and this is a very kind of stereotypical projectile motion kind of problem. All right, so the situation we have is the General Lee jumps over the riverbed 20 degrees above the horizontal at 32 meters per second. So I have to remember that this side of that vector is v horizontal. The constant horizontal speed the General Lee will travel at, okay, as it goes across the river, and that this side is the initial vertical velocity of the General Lee. It will only be that at the instant that this starts, and then it's going to change because of gravity. All right, so here's what we know. Acceleration's negative 9.81 meters per second squared. All right, the rest of the stuff we have to calculate. So VI is the opposite side of this triangle. So that'll be the sine of 20 times 32. Okay, so it's 10.94 meters per second. Positive 10.94 meters per second. Why is the positive important? Right, you're going up and down, and initially we're going up because we've just jumped off a ramp that's directed us in an upward direction. Okay, since we're talking about the entire flight of the General Lee, riverbed is level from side to side. How fast is the General Lee going vertically when it hits the ground on the other side? Negative 10.94 meters per second. What goes up must come down. Okay, so that's the information we know vertically. We also can calculate our horizontal velocity because it's the x component of our projected velocity here. So we're going to go cos of 20 times 32. so we got 30.07. Obviously, we're going to keep all those decimals for our calculations, but 30.07 meters per second. Right? 30.07. Okay. I want to calculate how far it is across the riverbed. That's the horizontal distance traveled by the General Lee as it flies through the air. What else do I need? Time. Have we solved for time in every question we've done? Yes. And in 95% of all projectile motion questions, you'll have to solve for time. Okay? The other 5%, time would be given to you. Those can be a bit trickier because you have to work backwards a little bit on those. Okay? So this is what we've got. We've got to find the time. Where can I find it? From my vertical information. Okay? I have acceleration and initial and final velocities. That means I can use A equals change in velocity divided by change in time. I just have to manipulate for time. So time will equal VF, which is negative 10.94, minus VI, 10.94, divided by the acceleration, negative 9.81 meters per second squared. So when I punch that in, okay, I'm going to have negative 10.94 minus 10.94, okay, and then I'm going to divide that by negative 9.81. All right, so the hang time of the General Lee is 2.23 seconds. It takes 2.23, so that's a lot of time to be flying through the air in a bright orange car. It's a lot of time to be flying through the air, period. Okay, 2.23 seconds. All right, that can come over here because time is the one thing that both vertical and horizontal parts share. Now that I have that, now I can say that D equals V horizontal times T. So that'll be 30.07 times 2.2. Okay, it's 67 meters across the riverbed. Okay, to give you some idea, the straightaway on this side of the track out back is 100 meters long. It's 2/3 of that. Okay, so they had the General Lee basically jump from one end zone on the football field, okay, to just past center field. 67 meters. Okay, it's a long way. So that's the first part of that question. The second part of that question wants us to calculate the maximum height of the General Lee. Okay, so what do I have to remember about this point here? There's two pieces of information that are going to change at this point. What's zero? The velocity. VF is 0 meters per second, and what else changes? Half the time, right? Okay. All right, so if I remember that, there's two ways for me to calculate the displacement. Okay, I can go that D equals, that VF squared equals VI squared plus 2AD, and I can solve for D. So I'd subtract VI. So I'd have VF squared minus VI squared equals 2AD, and then I divide both sides by 2A. That'll leave me with D. Okay, so I'll have 0 squared minus 10.94 squared divided by 2 times negative 9.81. That'll give me D. So okay, so the General Lee is going to make a height of 6.1 meters. That's basically like driving it off the top of the gym. Right? That's going to be pretty hard on any car, even the General Lee. Okay? All right, 6.1 meters. Questions on that one? Okay, so I've now shown you two examples of exactly what you're going to have to do for the projected at an angle question on your unit exam next Thursday. Okay? I would suggest possibly reviewing those a few more times. You're also going to have one projected horizontally projectile motion problem on your unit exam next Thursday. That's what we were working on the other day. Okay? Okay, this one's tricky. This one wants you to find the angle at which the projectile is launched. Okay, so it's setting up theta's unknown. Okay, it's thrown into the air at 35 meters per second. So I know the magnitude of this, I just don't know what the direction is. Okay, I need to find theta. So this has a triangle, which we talked about before. Okay, this side is V horizontal, and this side is V up. I would say that if I could find one more piece of information out about that triangle, I'd be able to find the angle. Would you agree? Okay, figure it out. This one, if you have a good understanding of what's happening, is mathematically quite simple. Okay, so this object's thrown into the air, okay, and it's going to do this. It's going to travel along a projectile arc, same as all the other things that we've looked at. Okay? What they tell us in this one, though, is a bunch of horizontal information that can save us a ton of time. Okay? They tell us that the object hits the ground 70 meters horizontally from where it was thrown. So they tell me the horizontal distance is 70 meters. And they tell me the time is 2.5 seconds. What can I calculate with that? The horizontal velocity. Exactly. I can get V horizontal from that information and have the second side of the triangle. And then it's just a trig calculation from there. Okay, so V equals 70 over 2.5. So that'll give me my V horizontal. Okay, so it's 28 meters per second. So now I know this side here is 28 meters per second. I know the adjacent side and the hypotenuse. All I have to do is find theta. Okay, that'll mean using cos. Cos of theta equals adjacent over hypotenuse. Okay, so theta will be the inverse cos or second cos of 28 over 35. Okay, so it was thrown at a 37-degree angle. Okay, so a question like that sounds really tricky when you first get it, right? Because it gives you a different set of data, right? It's not what we've been doing before. It gives you a totally different set of data. But what it does is it tests how well you understand the principles of projectile motion without taxing you mathematically, right? Because I mean, there was two calculations in that, and neither one of them is overly difficult, okay? But what was difficult about that question was being able to see the principles of projectile motion and how they could get you to the answer, okay? And that's oftentimes what we're trying to get from you is test your understanding rather than test how good you are at math. That's what math is for, okay? In physics, sometimes we give you a tricky question that actually isn't all that mathematically difficult, right? It's testing your understanding as opposed to your math. Okay, questions on that one? Okay. This one's really tricky. Really tricky. Okay? That's all you're given in this question. Okay? What I will tell you is you're trying to get both V and theta. Okay, you're trying to get V and theta, which means you need two sides of this triangle. You need VI and you need V horizontal. Or sorry, yeah, V horizontal. Okay? You need those two sides. The tip I will give you is the launch point and the impact point are level. Think about what that means for VI vertical and VF vertical. Think about what that means for them. This is an algebra trick. Okay? To get this question, it's an algebra trick. But if you have a really good understanding of the projectile motion stuff, you'll get the algebra trick. Okay? All right. Here's what we have to remember. VF and VI, if it's launched and lands at the same height, are equal, right? They have the same magnitude, but they're opposite in direction. So that actually means then VF and VI are the same number, which means I can calculate them both using this formula by doing this. A equals negative V minus V over T. They're the same magnitude. One's negative, one's positive. Everyone okay with that? Because they're the same number, I'm going to use the same letter to represent them. I'm just going to make one of them negative. This is the algebra trick. What's negative V minus V? All right, I know what A is, I know what T is. Can I solve for V? Now, does that give me the other side of the triangle? It's an algebra trick, okay? But you can't even get to the algebra trick unless you have that understanding that VI and VF are equal, but opposite in direction, okay? That's again, it's not like mathematically challenging. There was an algebra trick, but it was again an understanding test, okay? And that's what we're going to be looking at some more tomorrow. Okay? Remember, you've got your vector assignment due on Friday, and I will post tomorrow's quiz at the end of the day. It will be projectile motion questions. All right?